Today we are going to learn how to simulate highly detailed wall destruction. You can see how the pieces are getting bent and then getting breaking after reaching a certain threshold. We are also getting clusters that are sticking in the starting and then falling down and getting break into more pieces. Now let's dive into Houdini. Take a geo node. Take a box and adjust the parameters. Take a group node. Name the group as edge. Set the group type to edge. Now connect the remesh node. If you see carefully, remesh node has distorted our mesh. So to fix this, in the hard edge group add the group that we created before. Reduce the target size to 0.1. Add a rest position node. Now we are going to add noise for edge detail. So for that take a attribute VOP. Dive inside to attribute VOP and add anti-alias noise to its position using add node. Promote all parameters to SOP level. Switch the noise signature to 3D input 3D noise. Adjust the noise parameter. Add a scatter node. Before that, now take a VDB from polygon and turn off distance VDB and turn on fog VDB. Reduce the scatter points to 100. Again take a scatter node but with very less point. Then connect point replicate node and adjust as per your requirement. Merge both scattered points. Let's restore our original position using Let's restore our original position using Wrangle. Now for interior detail, we are going to use RBD interior detail. Increase the detail size to get more subdivision. And also increase the noise amplitude. Now you can see our normals are messed up. Let's add normal and fix that. Now it's time to make bricks. Take a grid node and adjust the height and width, same as wall size. Set the connectivity method to alternating triangles. Increase rows and column to 25. Now add group expression and set the group type to points. And in the vex expression we are going to use neighbor count function. The neighbor count function returns the number of points in a given point, in this case point number, is connected. If it matches with every eighth primitive, it's going to group the diagonal crossing points. Let's see within sketch example. This is our brick guide, which contains 8 primitive. The red lines are our primitive. As I earlier said, if it matches with 8, because we have give the value as 8 in expression, it going to group that point which will be crossing in diagonal path. Take a box and adjust the size of the box. Take a copy to point node and in the target group select the group that we created now using vex. Now merge both the geometry that we created. So now we need to move our brick slightly in x-axis. Now we need front wall also, which will be thinner than back one. So to do that, take a transform node and scale down in x-axis. And move the front wall slightly. Now we need to fracture the brick also. Let's fracture it quickly using Voronoi fracture. Merge all the geo and add a rest position node. Now take a connectivity node and add a name attribute. You can rather use assemble node to add name attribute. It's just a personal choice. Let's take a look at how our fracture has done. Now you have noticed we have exactly similar pieces in front and back. So to fix this, rotate the front wall in x-axis from centroid, so that the pieces will look different from back wall. Now take a pack node and pack it using name attribute and transfer the name attribute. Take a wrangle node and set active attribute, which will decide which pieces will be active in the simulation and which will be deactivated. If active equals 0, then the pieces won't be simulated nor any force will affect it. If active equals 1, then the pieces will be simulated. In our case, we don't want the bottom pieces to get simulated, so we are going to keep the active value to 0 for the bottom pieces. So in this vex, if the pieces are below 0.7 meters in y-axis, it will get the active value to 0. And if the pieces are above from the given value, then it will get the active value to 1. Now take a connect adjacent pieces and connect it to connectivity node, because this node require name attribute which should be present in primitive level. Now change the connection type to adjacent pieces from surface points. And adjust the parameters. Now we are going to make chunks using Verano noise. Take a attribute VOP and add a Verano noise. We need to jitter the edges. For that, first add an anti-alias noise, then add Verano noise. After that, export the seed attribute using bind export. Now we are going to look upon every primitive which has a different color. As you can see, we have a bunch of clusters. If you look at a single cluster, you can see in the middle we have the same color, but at the edges where the cluster is connecting to another cluster have a different colors. We need to extract that data. Let's do that. Take a wrangle node and write this vex. First, we are going to look at each line. And each line has 2 points, so we're going to loop over every prim. Let's store the primitive number for each point as integer data. As we have exported the seed attribute from VOP, we are going to look if the seed value is the same on both points, then we are going to keep that primitive in one case. Make sure to run the wrangle on primitive. Duplicate the wrangle for another case. And in another case, if the seed value is different, then we are going to keep the different ones and delete the same primitive. Now set the cluster constraint name as glue and the cluster to cluster as hard using a wrangle. Take a facet node and toggle on a unique point. Take a primitive SOP and turn on do transformation. And scale down it to 0 on all axes. As you can see, we have moved our hard constraint to its anchor point. Turn on point view to view the constraints. If you take a blend shape node and connect it to a primitive and second input to facet and increase the blend amount, you can see how the primitive has been scaled down to its anchor point. Now merge both the constraint and add a null, and we are ready to feed everything in DOP network. Take a DOP network and let's quickly set up our BD network. In the RBD packed object, let's import our sim pieces. Before that, please promote the name attribute from primitive to point level. Let's add a constraint network node and import the constraint network that we have created. In the second input, add a merge node. Now take hard constraint relationship and connect it to merge. Make sure that the name we set in SOP matches the name in the hard conrel node. As you can see, our pieces are getting away from each other. This is because we have moved our hard constraint to its anchor point. And in the hard conrel node, rest length is set to 1. So we don't need rest length. Let's turn down its value to 0. As you can see now, our pieces are not getting away. Turn off show guide or else the viewport will be too laggy. Take a glue constraint node and make sure to change the data name. Now we are going to set up RBD emission. Take a SOP solver and connect it to the multi-solver. Dive into the SOP solver and take a box node. Transform it in y-axis. Add an assemble node. Before that, add a normal node. Now take a wrangle node and let's set up some initial attributes. For velocity, I'm going to use the random function so that I won't get the same velocity on every emission. Now take an enable solver node and in the enable solver write this expression. This will going to emit every 8th frame. As you can see, when the box hit the wall, It's get cracked, but in the very next frame it's restored original position. It's happening because of hard constraint. The solver is trying its best to restore back to its original position. So to fix this, we need to tell the solver, don't move back to your original position. If you get deformed position is your new position. So to do that, take a SOP solver and connect it to third input of constraint network. Dive into SOP solver. This is a bit hard for new users. What you have to usually do is preview 2 to 3 frames, then go to the geometry spreadsheet. Pin that sheet and dive into the DOP network. Take an object merge and merge our DOP geometry. As you can see, this spreadsheet is a bit different from normal spreadsheet. All you have to do is go to RBD packed object node from left side, and click on plus icon. Then you can see geometry, click and drag it into object merge. Now we need to apply some vex in our constraint geo. As you can see, we already have a node called relationship geometry, which is importing our constraint network by default. Now we need only hard constraint, so let's split our hard constraint using split node by name attribute. Turn on point view to see whether we have splitted our hard constraint correctly or not. Take a attribute wrangle and connect first input to split and second input to object merge. Now, we are going to calculate 4x4 matrix using primintrinsic. As you can see, we don't have any attribute name packed full transform. These attributes are available by Houdini on demand. When we packed any geo, we get lots of attributes that are hidden in intrinsic. The next method is as similar as we did on the SOP level by using primitive, and scaling down the constraint to its anchor point. This vex do the same thing, but we need to apply this only if the angle of bending gets greater than the given threshold. Take a wrangle node and copy the vex code from SOP level. We need to edit a bit. We are going to use vector instead of integer. Make sure to run the wrangle on primitive. I forget to switch the runover method to primitive. I later fix this. Now I'm going to show that this is the same as we did on the SOP level. Now we are going to extract the rotation from the matrix using the quaternion function. Now merge the second output of split and the wrangle. The next step is we are going to remove the constraint if it's reached a certain given threshold. So to do that, there are lots of methods. You can delete that constraint, or put that constraint in the broken group. Bullet Solver by default deletes the constraints if it's present in the broken group. In this tutorial, I'm going to change the constraint name to soft, since we are not using soft constraint, so I'm changing the constraint name to soft. This Vex does, if the hard constraint bends more than the given value, then the constraint name get changed to soft. Since we are not using soft constraint, the pieces will get a break and fall down. Put an output node after the merge. Increase the substep to 20 in rigid body solver and decrease the constraint iteration to 1. In the glue control node, reduce the strength to 1. You guys need to play with the glue strength, constraint iteration, and angle value to get better results. I reduce the RBD emission velocity. Thank you for watching. See you in the next video.